I will talk about the lessons learned in procurement and risk management, and this was into my previous activity in Italy, 15, 16 years of design in timber structures, and then the last 4 years here in Australia, which have been exciting time. There is an Aussie way of designing mid-rise timber structure. This is just 6 examples of the 24 that have happened into the recent years. And as you can see, they are scattered around Australia. They are referring to different type of building, offices, residential, student accommodation, hotels. So, but they have things in common. They are designed in the Aussie way without needing just to follow the examples from Europe and Australia. Now we are mature in our market, and this is becoming a growing trend. It still is a niche market, but it is a growing niche. And the naked version of the 6 projects that were in the first slide show us why it is a growing trend. You can see how the construction site is neat and clean and safe and well organized, whether or not you build with scaffolding, whether or not you use a light frame approach, mass timber, post and beam approach. So different systems are all well suited to different requirements. And typically, the range of efficiencies and cost benefits that you can achieve by using timber structures are described by these 6 criteria. Sometimes 1 or 2 of them are more important in a given project. Sometimes they are equilibrated, but normally they are all present in a project. Like this photo here of the beautiful office built by Lend-Lease in Brisbane at 25 King Street shows. So if you understand this photo, my presentation is over. But it's not. The reason why there is an added value in using timber structures is because of the synergy of the combination of speed, safety, and quality. So actually, having safer workplaces will result in shorter programs, and it will have less variation into your construction schedules. Our advisory activity over the last 4 years, and we have 2 more to go, has centered around many different tools, our guides, our seminars, our demo building, but mostly a lot of project-related meetings, a lot of advisory directly with your design and development teams on your project to understand the requirements, turn it into a successful timber building. And the market share, which has resulted in everybody's activity into this, is that in 2019, there were 18 projects which were started or completed in mid-rise with timber structures. And we, based on that, we expected a growth of 20–30% per year in the market share. Currently, we are a bit more prudent, like everybody, but still we can leverage the effect of having less people on site, easier prefabrication into having a COVID-free construction site. And so coming to the lessons learned, we have put some of them into our guides, most of them in our guides, I would say. The guide 51 is the one that Lawrence and myself wrote in conjunction with Ryder Levitt Bucknell, and then the guide 50, Adam Jones will talk about it soon after me. So coming to procurement, I will quickly illustrate the light frame option, which is based on a very broad, diffuse, and healthy supply chain of the local truss and frame manufacturers. There's many of them. Some of them are smaller companies, others are big companies with a lot of automation, but all of them, they can supply componentry to like stud frames and floor cassettes into mid-rise construction. The key factor is their readiness for mid-rise, because most of them are into the well-developed Class 1 residential market, which revolves around the use of Australian Standard 1684 for the design or the detailing of componentry. So when you jump into the mid-rise, you need to adopt AS 1720 to actually design and calculate every single component. So not all the local truss and frame manufacturers have already engaged into that. Most of them have. So consult with them, ask them what they can do for you. And then cross-laminated timber is the new kid on the block. It's an amazing product, a jumbo plywood, we call it, which solves a lot of problems. It is based on some local manufacturers, which are well developed now, with 3 already operating and 4 coming soon, a range of suppliers from Europe. And the key here is, what are the services that these people who are already into the mentality of mid-rise construction can provide? They do structural design, they do shop drawings, they do transport and installation, if it is the case. And therefore, they add value to their product, and they add more comfort and ease to you as designers through their activity, turning a commodity product into a specialty product. This has already happened for years for the glulam. Glulam has been the first mass timber product available on the market for decades. In Australia now there are at least 4 local manufacturers which have a diffusion, national diffusion, and 6-7 suppliers operate from Europe and New Zealand. What is very important here is the performance specification, which in Australia differ a little bit from those coming from, or the products coming from the EU. And if you then click here, there is a link in our my presentation, and there is a specific part of our WoodSolutions website where these differences are well explained. Basically, for the same or a similar code, reference code, in Australia, the reference is made to the stiffness of the product. In Europe, it is made to the bending strength of the product. So you just need to understand it. We have a very clear table summarizing the differences, explaining, and then it is not difficult to proceed. So this product is more mature than others into the mid-rise market, and you will find a lot of answers from the suppliers here. But also, please consider LVL as a product with a high strength and stiffness to weight ratio. The performance specification, again, create a range of possibilities. You have 1 local manufacturer, 4 or 5 distributors from overseas, and they are all improving their prefabrication capacity to deliver excellent solutions for your projects. In terms of contracts, well, all the possibilities are open. The traditional contracts are very well efficient when the design team is experienced with timber and they can produce shop drawings that clearly define what they want and what the project needs. Otherwise, it's very interesting to use the DNC contract when buildability and site efficiency are a major driver of the project, and therefore the builder has a say and really can optimize it. And the ECI is the most modern and updated form of contract, and it really provides good outcomes when the contractor is experienced already, or they engage a supplier early and have a collaborative approach with the supplier. And this becomes, I mean, in a practical form, a way of designing for manufacturing and assembly, and considering the shop drawings and CNC time, machining time, are a significant driver of savings if everything is organized well, or additional costs if there is an over-design into this. So please click the link here and go to our webinar series and see examples like in the Latrobe project, in the Monterey project, in the Ballarat project. There's a number of projects in which the DFMA and collaborative approach and ECI approach are well described by the design and development team themselves and the builders. Some key consideration when you are comparing a big panel, whether it's a wall or a floor, to a more broken down into components type of approach. Well, there is not a winner. Both approaches are good. they may optimize a whole project or parts of a project. So please understand both approaches and use them as you need and combine them in your design. As the overseas suppliers are important in our market, we have provided a checklist into our guides. So please refer to this and to the guide and check what is applicable in your case. Often we have a question whether or not there is a cost premium, and there is not a cost premium in using timber when the projects are optimized, like Adam and Lawrence will detail after me. How to create more demand? By creating more supply. This will create more competition, and also a stronger Australian dollar will favor the imports and therefore favor competition. This is what we need. We need more suppliers to open up our market, and we rely on you to create the demand. What will the market need to see more local producers? This is our SWOT analysis, and we conclude that, like it happened in the USA when the global financial crisis triggered more mid-rise wood construction, I think the same is happening here. In terms of risk management, the key is understanding the combination of probability and consequences and running different scenarios. These are 4 typical issues that are faced or considered during the design phase, and even the most simple one, how if wood gets wet on site during construction, and it always does, the probability is very, very high. Nothing happens if it dries, and it's not difficult to dry it up, to let it dry, or consequences may be very severe if it doesn't. You may have rot if it doesn't dry out. So this is, for instance, our checklist, which is, again, in our guide for managing rain during construction and bringing wood moisture below 18% before starting the installation of plasterboard. All that you see here is something which is typical and common sense also in concrete construction, and builders know how to do it and do it. In terms of managing risk, we provide some examples on how to arrange comparison and a weighing of the different risks and coming to an understanding of what are the execution classes, which then turn into criteria for detailing and for choosing the right set of tolerances and checking the set of tolerances. This is based on European best practices and standard, coming from the Nordic countries, coming from the guys that did buildings like the Mjøstarnet that we presented in one of our webinars. Another very, very important factor to consider in de-risking your project is approaching the fire design from day one into the right way. You can use performance solution, you can use deemed to satisfy solution. We have a lot of support into this, both in terms of available documents in our website, and this type of documents are very much appreciated by the building surveyors, I can tell you. Or we support, we do new tests, we support and help you in organizing your test. And like this image shows, tests sometimes are really the best way to inform, to make people comfortable, to prove your design. And in a case like this, they prove that timber-based components are very, very robust into fire design. This was after 60 minutes loading, no delamination, no problems at all. So concluding the fire approach, we also have a guide for fire precaution during construction of large buildings, and it has been much appreciated by fire engineers, but it's a good reading also for builders, and we are updating this, so the new edition will be available very soon. In conclusion, I can say that the lessons learned can be summarized in this. Quality cannot be controlled on site if it hasn't been designed beforehand, if it hasn't been planned. So if you plan it well, you will really reap the benefits of timber construction in sites like this one. And these are two conclusion quotes from two very efficient builders who have pioneered timber construction, and this is what they say. It's a winner, it's a successful approach, the right way ahead. And with this, I'm concluded and leave the words to Adam.
Thank you, Paolo, and good morning, everybody, and thanks for joining us today. So my name's Adam Jones, and I'm a structural engineer with the Mid-Rise Advisory Partnership. So I started my career working at WSP on 50, 60, 70 story concrete and steel buildings. And then I kind of saw the light in terms of the sustainability point of view, which really drew me to timber, where I've been the engineer on the team for a few years. So what I'll be covering today is the timber first paradigm and lessons for successful design. A lot of this might seem pretty simple and basic stuff, but it is really absolutely critical if you're going to have a successful project when it comes down to timber. So the first slide I'd like to show is that you can't really fit a square peg in a round hole. You can try if you just nudge around the edges, or if you put all the force you possibly can into it, or if you yell at it, or you can do all you can to get it in. But from the very start, it's much easier to just have a round hole for a round peg for a round hole, so to speak. And this is really what it's like when it comes to timber buildings. If you start with a paradigm that comes from concrete architecture and you apply those kind of principles to a building, and then you try and let the timber fit within it, yes, you can do it eventually, but it's going to be a lot more effort than if you just got the design principles right from the very start. So in my presentation, what I'm going to be covering is just what does this round peg look like? And if you tick these boxes, you're going to be skiing downhill, and it's going to be very likely you'll have a very cost-effective and successful project from a design point of view, compliance, and buildability. So first of all, I think no matter what project you come across, you're always going to have, at the start, concrete on the table at least. When you're looking at timber, you're comparing it to concrete. So it's really important to understand how both materials work and where one might be suitable than the other, and how to leverage the advantages and benefits of both. So if you look at concrete, what you typically get is a flat plate slab. You can get a 200 thick section spanning about 6, 7, 8 meters in both directions. So if you look at an apartment, the way you might frame something like this, you could have blade columns in the interparty walls or the internal walls, but fundamentally you can get the 6 to 8 meter spans. And what you really need to do is just align the blade columns, which might be only 800 millimeters long. And then the rest of your walls, you've got a lot more flexibility. So you can change your walls as you go up the building. So if you're looking to avoid transfers with the concrete building, you just need to align the blade columns, which are pretty small sections. When we're looking at timber, we've also got a two-way action we can utilize, like CLT, for example, the top layers. Not sure if you can see my mouse at the moment, but the section with the top layers and the middle layer here, you can get quite a decent span of, say, 6 meters or something. If you're pushing beyond that, you can start getting a bit deeper than the concrete equivalent. And the secondary layer, however, you've got less timber away from the neutral axes. So yes, you get the two-way action, but whereas concrete, you can get 6 to 7 or equal spans both directions. With timber, you can have one dominant span. So if you're looking at the most simplistic way of looking at it for the round hole kind of, or the round peg kind of philosophy, timber is really should be seen as a one-way spanning material when you're doing your layouts in the typical scenario. And I'll show later an exception to that rule with a posts and plate system. But with that, your open to wall products, you got floor trusses, you got your cassettes, and you got everything like that as well. So you're open to wall products, and you can get the most efficient design. So back to our apartment we had earlier, which I showed you with the concrete structure. When we're looking to lay out our timber projects, there are really 3 different things, and it's subject to a few more than these 3 things, but fundamentally, these 3 things are the things you're going to have in the back of your mind. The buildability, keeping in mind that the critical path for the build is going to be the amount of lifts on the project, so you want to reduce the amount of lifts. The cost of fireproofing. So this is a really big one, and I've noticed recently it's driving a lot more design decisions than I used to think. So if you think about the inter-party walls, so the bottom and top walls here, if it's non-load bearing, it's a 60-60-60 requirement. So you do need plasterboard. If it's load bearing, you need a 90-90-90. The internal walls, however, if it's non-load bearing, you don't need any plasterboard and to fire rate it. So whether to make that load bearing or not does impact on the amount of plasterboard and for your project. And the third, which is very intuitive and the most obvious, is just the cost of materials. You want a really efficient spanning system, so the actual structural materials are at a minimum. So the higher spans you have, for example, obviously the thicker floor you're going to have, and you're going to drive up costs. But these three things have their benefits and trade-offs, and something that's very efficient on the cost of materials might be less efficient on the cost of fireproofing and so forth. So I've applied a little star rating on a few different ways you could frame this apartment. And these stars here, they're absolutely up for debate, but just to speak at the high level about the different decisions. Something like this, you got the, excuse me. Something like this, you've got the shortest spans. And from a floor perspective, it's very efficient because you got the continuous span over the internal wall, which drives down the size of your structure. And that means it's going to be very competitive with your concrete alternative. And you can really meet those 3.1 metre floor-to-floor heights that you get in your typical buildings, typical concrete buildings. But with fireproofing, you do need to plasterboard those internal walls completely, and also your power points and everything like that. Another option, you might do a mixture of load-bearing walls plus post and beam. So with this, you can use your beam as your internal wall here, and that means you don't need to fireproof your power points and everything like that. And so that will go down, and it's a bit easier from a fireproofing point of view. However, the cost of structural materials might be a bit more, and it's about the same in buildability as the previous example. Now, this one's really for the taking for anyone who wants to go down the post and plate route, because you could argue it is by far the easiest to build. And Brock Commons, for example, in Canada, they had an 18-story building, which had I think they were doing 3 floors a week or just something totally insane. And that was because with your columns, you can do one single lift with a bunch of columns. And because they're quite light, you can manually put them in place. So the critical path being from the crane, it reduces the amount of lift significantly. And it's very easy to just pop, in this case, with the CLT on top to get a two-way action in this case, with the second span, much less than the primary span. So as I said, these stars, they're by no means the rules, but it's just something to keep in mind, the trade-offs when you're making the decisions of the apartment layouts. So if we were to just have a takeaway of what the round peg really looks like, it's typically spans of 3 to 6 meters. Anything above 6 meters, you're starting to move away from that round peg. And I must just quickly mention, we're talking about apartment buildings here. You can go out of that in office buildings. We need to avoid transfers as much as we can. So any transfer of load with a one-way system is a bit more complicated to get it back to its load-bearing supports. And also have, as Paolo was saying before, have some DFMA in the back of your mind. The more complexity you're adding to the floor plate with angles and everything like that, absolutely can be done like everything, but you're going to be adding a bit more complexity inside the factory, which is going to be part of the cost in addition to the material costs. So you can definitely go outside of these 3 criteria. It's a bit of a dichotomy. I think you can go the extreme far the other end and have a lot of complexity with timber, because you can utilize CNC fabrication and design optimization to get structures that are extremely complex. But also, if we're looking for efficiency, simplicity is something to go for. I think it was Einstein, maybe, simplicity is the ultimate sophistication, which is the case with timber. So looking at a few case studies. So in Victoria, this is a project that really beat the concrete equivalent, because they did these check boxes and had a very successful project. So as you can see here, as you go down the building, no transfers. They've got a span that's under 6 meters, and they're loading onto the interparty walls and not utilizing the internal walls as load bearing. So this is a very efficient structure from a floor point of view, and those 3 criteria I just mentioned. And if you look at the walls, as you go up from 2, 3 to 6 stories, you can scale up your traditional residential design. So your 90 by 45 MGP 10 at your 1 or 2 story, you just scale all the way up the building, and toward the bottom of the lower floors, you can have higher grade studs at increased or decreased spacing and so forth. So again, just another framework when we're looking at the walls. You can go light frame up from 3 to 6 stories. Obviously, you can use mass timber for 3 stories plus, but somewhere in between, you might be looking at a hybrid if you're looking for the most efficient solution, where you've got a CLT combined with light frame. And this is what this project has done. So the builders out there who are really getting some under the belt, they're looking at architecture that does apply these kind of criteria. Just keep an eye on the time. I might move on. So office buildings. So there's 2 typical frames we can look at. So a 9 by 9 meter grid or a 9 by 6 meter grid. 9 by 9 you can take all the way down to the car park grids. 9 by 6, beautiful and simple from the upper structures, but you might need a transfer to get back to the concrete grids and the car park grids. And buildings like this is the beautiful 25 King Street. So when Dean Ashen joins in for the Q&A, you'll see he's sitting in this building at the moment, actually, around one of those columns. But you got a 9 meter glue lam spanning in this direction, back towards the core. And you're going to simply just sit the floor panel on top. And then one of the lessons we've learned is that services is actually what dictates a lot of the structural grids and the design. So you want to orientate things to minimize the amount of penetrations as much as possible. And this is what this building does very well. So services can run parallel with the primary beams, and you can see that final span being a little bit shorter and a shallower glue lam, and it's very easy to take back to the core. Or you can take the 9 by 9 meter. And so another beautiful building via Lend-Lease here. And again, with the primary direction or the primary span, you can use a glue lam or LVL beam in this case. But again, that secondary span is going to be very important to get as shallow as possible, so you've got somewhere to run your services. And there's some really new innovative solutions from the supply chain. So you can use something like a glue lam ribbed deck system. So CLT on top, and you're using screws and glue to get the composite action here. Or you can borrow from the concrete paradigm and do band beams, whether it be LVL or glue lam. And of course, LVL cassettes. So LVL being very efficient in terms of stiffness per unit weight. With a box section, you get a very stiff section to get that 9 meters, and probably looking about a 450 deep section, which is very reasonable for an office project. So thank you everyone for listening. So the one takeaway, as I said, when you're looking at a timber project from the very start, just keep in mind if efficiency is the goal and you're trying to be competitive with the concrete solution, we need to design our buildings from a timber first paradigm. If you do that from the very start, the design process, construction, compliance, the whole lot is going to be downhill skiing, and you'll be well on your way for a successful project. So thank you, and I'll pass it over to Lawrence.
Righty. Beautiful. All right. So g'day everyone. Thank you very much, Adam, and thanks to Paolo as well for a couple of really interesting presentations. Hopefully I'll be able to sort of build on those a little bit, provide a bit more clarification in the costing side of things, and also we're going to talk a bit about programming. So my story, just very briefly, I joined WoodSolutions back in 2017 with very little knowledge of timber. I came in as, I guess you could all, very much a part-time role. But since then, I've learned a huge amount, and that a small amount of that, but I think some of the more valuable lessons are included in today's presentation. So let's dive into it. We'll There we go. All right. So when I joined back in 2017, and actually when the program started in 2016, we had these 2 technical design guides available, guides 26 and 27, which you have since been updated, as you can see, and you can download for free from our website. And basically what these guys said is number 26 is a direct cost comparison of an office building, 7-story office building, 9-metre spans, as you can see in this sort of pretty generic plan. And it compared a reinforced concrete solution with a mass timber solution, which primarily utilised LVL, mass LVL. And you can see there's a really significant cost saving there in that design. 27 looked at the multi-residential space, which obviously, as Adam just went through, does experience kind of slightly different dynamics from and requirements from a floor span and other requirements. And here you can see, very typically, we saw a 7-story apartment building over a 1-story concrete podium slab, and again, really significant cost savings. So when I started, doing a bit of analysis, we could really identify 3 really significant areas of cost saving. And as you may have picked up already, it wasn't necessarily the actual timber, which is where the cost saving was. So if you were to compare, a cubic metre of reinforced concrete with a cubic metre of timber, that's not necessarily going to give you the realistic saving which you might be expecting on a timber project. The real savings, or the real cost impacts, were coming from a faster delivery, so reduced program, reduced preliminary costs, which, as many of you will know, are costs sort of associated with the construction of the project, which aren't actually going into the building or aren't left with the building when the builder leaves it. So a good example would be council permits or crane hire. Obviously, they're required for the building to be completed, but you don't leave them there once you've hit practical completion. And then, of course, smaller footings, which means, of course, you can save cost by having fewer or smaller piles or smaller pad footings than you would do with a traditional reinforced concrete project. Or alternatively, you can build a bigger building for the same size footings, which we've seen being actually quite a big driver around the world. So this is what we found based off those guides back in 2017. 4 years on, from 2016, I should say, when we started, we've learned a huge amount. And really, those 3 areas of savings are still absolutely realistic and still absolutely represent significant areas of potential cost impact and program impact in a project. But as Paolo introduced earlier, we recently, in the last couple of years, put together and collated information for this technical design guide, number 51, which obviously is quite a few years down the track from 26 and 27, which really communicates the lessons which we believe we've learned. Now, there's far too much here for us to cover in a presentation, let alone in 10 to 15 minutes. So I'm just going to really focus on, one area, which we'll get to in a second. But so this guide is based on our experience in the industry and in the marketplace, but then also the experience from 26 significant timber projects from Australia and comparable markets. So you can see we've kept them anonymous here for privacy reasons, because we did get some really good quality information. But of course, you can't always share the name or address of a project when you do receive that sort of information. So well worth having a bit of a read of this, because it goes much further in depth than we're going to go today. So the area that we're going to look at in this short presentation is design optimization, which is funny. There's obviously a bit of a theme here between our 3 presentations. It really does come down to the early stage, making sure you are designing for timber and that you're considering all of the different requirements and the potential benefits of actually working with timber at those early stages. Now, in the guide, we also have a couple of case studies at the back, which actually really, really well illustrate how these concepts can actually be applied in reality. And it's a good sort of update from the earlier technical design guides 26 and 27. The case study is on this project, which is actually down in Caulfield in Melbourne. So it's a real building, and we actually worked with Ryder Levitt Bucknell, who you may know, quite a large quantity surveyor and cost manager, cost consultant, I should say. And we got some really interesting results. So what did we look at when we were actually looking at this project from a design optimization point of view? So first, Adam has touched on this already, and he's given a really good sort of overview. But I'm going to say one of the more fundamental aspects of a timber design, if you do want to see really significant positive cost impacts, is to look at the load-bearing structure of the building. Obviously, the vertical loads at the bottom of the building, as we can see here, you've already seen this chart, but the vertical loads at the bottom of the building down here are much higher than they are at the top of the building up here. Obviously down here you have the whole building, all the loads from the whole building coming down through these elements, whereas up the top you're really supporting just those top couple of levels of the building, plus obviously any wind loads which you might be transferring through any sort of shear elements in there. And what that means is that we can really design a building for the loads which it is incurring, which means that at the ground levels, at the really lower levels, you're going to have a really high strength element. But as you get higher, you can reduce structural grade or reduce the section size to essentially design for the loads which you're actually going to be incurring in that space. And that just avoids over design. Here obviously I've shown mass timber at the bottom and lightweight framing at the top. That might be mass timber throughout. It could be a 150 mil thick panel or a 400 by 400 column at the ground floor, and then at the top it could be say 90 mil panel or a say 200 by 200 column, just as an example. So that's a really important takeaway which I've learned from a costing point of view. Timber can be cheaper, absolutely, but it has to be designed to be cheaper if that's really what you want to achieve. Now, acoustics are a really big area, especially when we're talking about timber projects and especially in multi-residential situations. As you can see, class 2 and 3, so that's typically student accommodation or multi-residential, sometimes hotels. They do have quite strenuous acoustic requirements under the NCC, and we do typically have to provide an extra solution for our timber elements, our load-bearing timber elements, whether it's a floor or a wall system, to meet those requirements. It's once again, it's not a difficult thing to achieve, but it has to be considered early in the project, and you have to actually look at what works best. What integrates best into the timber construction sort of methodology, because we're not dealing with a wet site here. We're dealing with a dry site, and we're looking at essentially maximising our program savings. So we really need to consider that in the floor elements and the wall elements that we're looking at using. We can provide a lot more detail with this. It's a bit of a speciality of our office. So if you do have a project, if you do have questions in this space, please do get in touch. Now, you've already seen this chart again from Paolo. We're going to touch on it really quickly in a little bit more detail, I think. So we're looking at optimization from a fire point of view. And when we are talking about fire in timber buildings, from a compliance pathway, we essentially have two different ways we can go. One which is a performance solution and one which is the deemed to satisfy. So looking at the deemed to satisfy first, just as one of the pathways, if we do want to follow this pathway, it means that essentially we have to follow the recipe which is outlined in the National Construction Code, which is quite easy, essentially. They give you really straightforward instructions, but of course it can lead to potentially a bit of over-design for the project. Because of course what is in the NCC has to be applicable for all types of project in all situations. So you have to consider the worst case scenario, essentially. Whereas your project may not be the worst case scenario. So you might be over designing a little bit from a fire point of view. As you can see here, this is just a deemed to satisfy solution of a timber project. And one of the first things you might notice is that you can't see any timber. and that is one of the limitations of the deemed to satisfy. So from an optimization point of view, deemed to satisfy for your project is typically a simpler way to go. It can be sometimes a faster way to go, but depending on the project, it might result in potentially some extra cost or some wasted cost, I should say, in fire rating that you might not need in your design. If we look at performance solutions, really, you can see this as apples and oranges, really. Performance solutions are essentially there for projects that don't want to follow the deemed to satisfy, and they require a fire engineer to model the behaviour of a fire in that space. As you can see, you can get some really beautiful aesthetic outcomes, and you can get a bit more efficiency in that fire design. But of course, there can be other costs, such as a consultant's fee associated with that. And then really buildability. We've already touched on this, and this is actually the Brock Commons, which Adam touched on at the end of his presentation. And you can see, once again, sort of confirming what he said, the columns, because they're quite a close spacing, could literally be installed by people. So the crane would pick up 10 columns, drop them on the deck, and then the installers could go around installing them by hand. This is a great thing for program, again, and it really just shows the importance of considering the buildability and the design for manufacture and assembly, DFMA, the impact that can have on the overall cost of the project. So, in summary for this very short section of this presentation, the most successful timber projects are those that are designed with timber's strengths in mind. So whether that's the spans that Adam was talking about earlier, or we're talking about the load-bearing ability of, say, a mass timber panel versus a lightweight timber panel, it's really important that we understand what we can be using in different parts of a project to really make the most of that product and really make the most of the money that you're spending. Expert consultation and advice can find extra efficiencies and savings. So, of course, we're talking about us there. Get us involved, talk to us. We're fully independent. We're free to use, and we have quite a bit of experience under our belts between the team. So we're always more than happy to support you in your next project. And finally, of course, timber construction can be faster, safer, and less disruptive than other alternatives. We've seen it over and over and over again. We obviously get out there and we say a lot of words, but then we do see this really happening in projects, and we'd love to see it in a project with you in the near future. So that's me, very briefly. If you do have any questions, feel free to get in touch. But of course, you can contact any of us just through the WoodSolutions website as well. So thank you.
So now we'll move to Q&A, and I'd like to introduce Dean Ashton. Dean is one of our development program managers and is based in Queensland. He's going to facilitate the Q&A. Over to you, Dean.
Yeah, thank you, Jennifer. As Adam mentioned it as well, I am based up in Brisbane, and I've got an office in 25 King Street, the project that both Palo and Adam showed you. And you'll be able to see just over my shoulder there, a lovely 480 square glulam column. So in this building, it really takes advantage of the exposed timbers. So it's all exposed post and beam, as well as the ceiling system. So you get the real advantage of the biophilic design as well. Before we get into the questions, I just wanted to reiterate what Lawrence just mentioned as well. Please feel free to use us. We can only cover so much in a 1 hour presentation, and the way to really learn about what you can apply in as far as timber buildings is to get us involved. So, our name is Wood Solutions. We're here to provide you solutions to be able to use more wood in your construction. And I think also the Mid-Rise Advisory Partnership, we have industry partners, but we also like to see ourselves as partnering with you in your upcoming projects. So I'm sure every company that's represented here today, there's opportunities for you to have a timber champion within your business. So please feel free to get one or two of your colleagues together, get in touch with us, and we can arrange for some meetings to show you what can be done. Okay, so we'll get into the Q&As now. So the very top one here from an anonymous attendee. One of the issues we are dealing with now is the repairability of timber elements, beams and columns on site, especially GLT, glue laminated timber beams. where they are fabricated in workshops. What are your recommendations for repairing existing connections or constructing new connections, replacing a part of the beam on site where a contractor can carry out the works? I think Lawrence also mentioned that with a lot of the mid-rise type programs, and Paolo mentioned the earlier contract involvement, we also, one of the things is getting the early supplier involvement. And a lot of that is to do with design for manufacture and assembly. So a lot of the times on these mid-rise buildings, a lot of the connections are being designed in right from the very start. So, the glulam beams are probably processed in the factory to allow for brackets and everything to go in. So it really, I guess it comes down to the specific applications. One of the real advantages of timber construction is that you're basically just using handheld screw guns to drill in screws or tighten up nuts and bolts. So I'm sure there are ways of retrofitting connection details if something doesn't go quite right on site. But really, ideally, particularly with a mid-rise building, we're wanting to make sure that before the product even gets delivered to site, that we know how all those connections are going to go. So maybe Paolo or Adam, you'd like to add a little bit more onto that as well?
Look, I've been doing a lot of consolidation of heritage timber structures in Italy in the past. And it was about repairing the effects of time and exposure, unforeseen exposure or mechanical loads on structures. And I can tell you it's easy, of course, to repair a timber element with different techniques, whether it is just metal or metal and glues, etc. And it depends very much on the degree of reparation that is needed. If it's really a wrong positioning of the guidance holes for bolts, then it's much more difficult than repairing some bumps or scratches during transport, okay? But you can easily, everybody can easily imagine that the same skills that are used in cabinet making are the basic skill in dealing with the aesthetics of timber repair. And the same skills which are used in carpentry are those which are used in repairing eventual problems of structural nature or geometric nature. Not difficult.
Yeah, thanks, Paolo. And Adam, from an engineering point of view, do you have any more to add to that?
Not really, Dean. I think you've covered it pretty well, and same with Paolo. So as you said, ideally DFMA, get it right from the very start. It just shows that you're much better off spending that little bit of extra time in the design phase to get everything right, and then when it's on site, ideally it's perfect because it's going to take a lot longer and it'd be a bit more expensive to rectify when it gets to that phase.
Yep. Thanks, Adam. The next question down from Kyle, probably Lawrence might be able to add to this. Do you happen to have some comparisons cost-wise of stick frame with mass timber that accounts for M&E and fireproofing? Well, I think before we get into Lawrence, Lawrence did touch on it before with the whether we're going down the deemed to satisfy path or we're going down the performance solution path. Typically, stick framing is usually deemed to satisfy. We usually have fire-rated plasterboard covering the elements. When we're going down the mass timber, it could be a performance solution if you want to have express timbers to be able to visually see it. But if you're going down the deemed to satisfy, the fire-rated plasterboard will be different requirements. Typically on the light frame, you need a double layer of 13mm plasterboard each side. With the mass timber, you only need one layer of 16mm. So there is, it's not just the cost of the material, you've got to look at the whole system. Lawrence, you might like to add a bit more.
Yeah, absolutely. So, look, really good question because this is, what we're talking about when we're talking about cost comparisons. As you were saying, we're not just comparing the timber part, we're comparing the timber, the fire design, the acoustic requirements, the complete solution, or I should say the complete system, because that is, at the end of the day, what is delivering the structure, and that is, got to change depending on what structural material or system you use. The simple answer to this is that not necessarily. That there's nothing beyond our technical design guides 26 and 27, which look at a purely a lightweight frame or a massive timber solution. There's nothing that actually is a costing of the hybrid. And the reason for that is because it's so project specific. We actually do this regularly in our sort of day-to-day role in the Mid-Rise Advisory Program. We look at projects, we'll help them sort of be optimize their design further, which might include the use of some lightweight framing in spaces or mass timber in other spaces. And then we look at what impact that has for your M&E, your fireproofing, and all those other sort of requirements. And then finally, we can look at the cost and the cost impact of that. So unfortunately, no, we don't have a direct reference, but it is a process that we go through regularly on unique projects. And of course, we'd be more than happy to do it with you as well.
Thanks, Lawrence. Next one is also from an anonymous person here. How does it compare to RC buildings in terms of maintenance? Well, I guess any building will require maintenance. Timber, obviously, there is durability issues that we need to make sure that the waterproofing doesn't get affected, because if the timber is constantly wet, I think Paolo mentioned earlier on that you could get decay. But even a concrete building, if you got water leaking all of the time, you're going to have severe issues. So I think any building requires regular maintenance and inspections to make sure that the building is performing as it was intended. So anybody else like to add to that question?
Yeah, look, the typical answer that we give in these cases is look around you. In Brisbane, for instance, you, Dean, are in a beautiful, modern 10-story timber building, but in the center of the town, in the CBD, there is a 10-story timber building which dates from 1913. So it's over 100 years old. With good design, good installation, good maintenance, it is still there. It is an hotel. We've slept there and it is comfortable. So it's really about not the material, but the way we use it.
Yeah, I would absolutely agree with that. In that, you know, if we're looking at a timber element, particularly a structural timber element, but any element which is outdoors, exposed to the elements, whether that be sun, rain, wind, whatever it is, then of course that is going to require more maintenance and more checks than, say, a precast concrete element might. But if we design for timber correctly and it's enclosed in a pretty safe building envelope, as certainly that example in Brisbane is, there's little requirements for extra maintenance beyond you know, the occasional check if you have exposed systems or particularly high risk parts.
Yeah, that building that's over 100 years old, it's basically a brick veneer construction. So yeah.
Yeah.
The next question is, what are the biggest hurdles to timber going mainstream? Well, I think a lot of it is education. We're just at the tip of the iceberg. You know, there's so much potential for timber. You know, we know about a lot of the benefits of timber. It's a natural product, store carbon, renewable, lightweight. So there's a huge benefits. But a lot of people don't realise that they could be using timber for these structures. You go over to the US and they're doing quite a lot of lightweight timber framing for 6-story buildings. That's mainstream over there. That's for apartments. It's yeah, it is mainstream. So Australia, I think, is at the tip of the iceberg, and you know, give it a few years, and we're going to see a lot more timber buildings.
Yeah, I'd like to reiterate what you're saying there, Dean. I think when I first joined the MAP last year was, or a few years back, it was having enough design teams with enough knowledge. So now there's an unprecedented amount of builders who've got their first 1 or 2 projects completed. Same with engineers, same with architects. So, you know, I thought that was previously a big hurdle, and let alone the cost estimating, which has been a huge hurdle, but the cost engineering guide has helped. But then also the drivers, the push forward, sustainability, global warming, it's not going anywhere soon. So that trend is just going to increase going forward, and the importance we're going to place on that. That's being reflected in councils' timber first policies. It's being reflected in rating tools like Green Star. So they're mandating a minimum reduction in embodied carbon for all 5 and 6 story buildings. That's going to be ratcheted up going forward. There's also just more consciousness around biophilia and the importance for designing buildings for human health. So having that exposed look as well is a real push forward. So, I think we're in a fantastic position. It's going to be very, very positive in the next 5-10 years going forward for timber mid-rise buildings.
Yeah. I think we've got time for maybe one more question. I think we're about one more, yep. Cole's already asked a question, so I'll skip over. Here's another anonymous one here. If I want to build a 5-story apartment building, you see them all the time now, what would be the most cost-effective timber solution? And I think Lawrence and Adam both touched on that to a certain degree. It really depends on the layout of the structures. And as I said, in the US, they're doing a lot of lightweight timber framing. Mass timber could be used. I know there's a 6-story apartment building in Sydney where they use lightweight timber framing for the walls and then a CLT floor slab for the floor system. So you could be looking at a hybrid system as well. But if you've got any particular projects that you have in the pipeline, please feel free to talk to us, and we can certainly have a look at maybe what the best way of getting timber to work for your project.
Yep. Just to add to that, I agree with you completely, Dean, in that, it just depends on the design. We often find if a project's already gone to planning and it's stuck in at a very specific total structure height or a floor-to-floor height, that can really determine what structural system we use. But if you're starting out a 5-story project from, day dot, you don't even have a concept design or a massing at this stage, the cheapest system typically, or the most cost-effective system, I should say, typically for a 5-story multi-residential project would be lightweight framing. And we've seen that realised over and over again. The classic example is a great project in Parkville in Melbourne called The Green, which was built by Australand, who are, of course, now Frasers. Back in 2015, I think it was. And they've been quoted as suggesting that project came in 25% cheaper than the alternative in situ concrete. So while you might struggle to get 25% savings on your first project, you might notice that none of our costing guides go to 25%. After a few projects, when you have a bit of more experience, maybe that's possible. But obviously the lightweight framing solution is the most cost effective. If it is, if you're starting with timber in mind and you have essentially, the world's your oyster, lots of options open to you. Yeah.
Thank you. Thank you, Lawrence, Adam, Dean, and Paolo. That was very interesting, and I know from the feedback that we've been getting on the chat room there that people have been very impressed with this. The survey form will be sent by email, and you will have the 3 questions for your formal CPD points. So again, please store this in a safe place. Just on the presentations, this webinar will be available on Monday at the WoodSolutions website. So you can go back and review the webinar. You can also share it on YouTube. So if you'd like to share it with colleagues or clients, please feel free to do so. These webinars, I believe, will stay indefinitely on that website, so you can review past ones as well. We have some of the resources available to you are our Timber Talks podcasts, and some of the recent topics you can see there on the screen. So again, these are available and able to be shared. So we would really encourage you to do that to spread the word. Next webinar series, next week's webinar will be on the 22nd of September at 11 a.m. using cross-laminated timber in residential construction. So you'll be able to register for that, if not now, very, very shortly, possibly tomorrow. I again want to thank everybody for attending. We really appreciate it. There's been around about 400 people today, so that's a fantastic outcome for us. Thank you to the presenters, and we look forward to seeing you all at the next WoodSolutions webinar. Goodbye, have a great day.